Okay, I want to talk about Treasury notes and Treasury bonds. This comes from Chapter 14. Treasury notes are less than 10 years maturity, so 1 to 10 years maturity, and Treasury bonds are more than. That's the only real distinction. We're not going to get into more detail than that. Think of bonds as a money machine. They have a promised payout rule. So there's a physical certificate. And that physical certificate describes the payout rule. We have to determine that first, because remember, the value of any financial asset, the value of any money machine, the value of a treasury note is the present value of the expected future cash flows. So first of all, we have to determine what the future cash flows are going to be. So we'll say this treasury note or treasury bond, whichever one was issued some years ago, and we will say today is November 30th, 2011. We'll say that this bond pays, in treasury notes and bonds pay either on the last day of the month or the 15th of the month. It depends on the type. We'll say that this pays the last day of May and November. So if it's a bond that matures in November, and you know they pay semi-annually, all treasuries do, almost all bonds do, you know they pay semi-annually, you know it pays in May and November. So we need to draw a timeline. It'll be something like this. So this is 11/30/2011, and the question now is, when does this thing mature? So let's say that it matures November 30th, 2014. So if that's the case, it's going to pay May 31st, 2012, November 30th, 2012. It doesn't pay May 30th, right? Because the last day of May is the 31st. It's going to pay May 31st, 2013, November 31st, 2013. I'll tell you what, let's make this easier. Let's just say that matures in 2013. So we just have 4 payments. It's going to have written there as well a coupon rate. The coupon rate, let's say, is 8%. So that lets me know my payments, because I also need to know the par. The par is $1,000. So the par is $1,000. 8% of 1,000 is 80, but pays twice a year, so 40. So it's going to pay $40 every 6 months, and then when it matures, it pays $1,000. So it's going to have payments of $40. N is equal to 4. Think of this as the payout rule. Then I, as an investor, need to determine what I call the yield to maturity. So you want me to essentially loan money to the government. So when I loan money to the government, what interest rate do I need? Well, let's say I need an interest rate of 8.2%. So if I say 8.2%, I mean an annual rate of 8.2%. My calculations, I divide that by 2. So the price of the bond today, so the zeros for it, times 0, is going to be equal to the present value of the expected future cash flows. That's 40 divided by 1.041 plus 40 divided by 1.041 squared plus 40 divided by 1.041 cubed plus 1,040. Having trouble writing. 40 divided by 1.041 to the 4th. That's equal to 996.38. So this is how I price a bond. In the very simplest terms, I know this portion. This is what I call the payout rule. This is written in a legal document that tells me what the promise is, and then I determine the rate I need to loan to whoever it is. In this case, the Treasury is 8.2% annually, or 4.1% semi-annually, and I can determine the price. Okay, so let me now go to some other details. This was the simplest cases we could possibly have because we said today is November 30th. Right? So if today is November 30th, I want to know, hang on just a second, sorry, got distracted by something. If today's November 30th, well, what if I bought the bond not November 30th, but what if I bought this thing December 15th, 2012? How does that change things? All right. So what we need to think about next is a concept called accrued interest. So look at the accrued interest. So today is December 15th, 2012. Like I said, the Treasury, the U.S. Treasury makes payments of $40 on those particular dates and then $1,040 on this date right here. But the interest payments are $40. Who do they make those payments to? They make the payments to whoever owns the bond. But the problem is the bond changes hands many times, perhaps not, but probably changes hands many times during that coupon period. During the, it doesn't just trade on November 30th and May 31st. So what if you sell a bond on December 15th? Then you don't get any money. The next payment coming up is that should be 2011 over here. Let me erase that. So if you sell it December 15th, 2011, then May 31st, 2012, you don't get any money. The person who owns the bond at that time is the one that gets the $40 payment. Right. So we have to determine is how much money you deserve. Okay, interrupted by a 5-year-old. Sorry. So the question is, if you sell the bond, so you sell the bond on December 15th, you won't get any money on May 31st. But you deserve some money because interest has accrued. You've earned interest. You've accrued interest. You got paid, let's assume that you owned it in November. So you get paid in November, you got your $40, right? Now you've owned the bond for a portion of time, but you get nothing here. So let me give you the analogy of rent. Say that you move out of an apartment on the 10th of the month. Somebody else moves in on the 20th and stays the rest of the time. How much of the rent do you owe? You lived in the apartment for 10 days out of the month. You owe about 1/3 of the interest, right? I mean, 1/3 of the rent, right? It's the same thing here. We're trying to prorate this. So the question is, that $40, what percent of the $40 should you get to keep because you own the bond in this time period? All right, remember when we talked about T-bills? I said T-bills have an actual 360-day count, which I don't know why they do that. Treasury notes and Treasury bonds have what's called an actual day count. So what I want to know is the number of days from November 30th to December 15th. Guess what? That's 15 days. And I want to know the number of days from November 30th to May 31st. That is 183 days. You just have to count that up. It's going to be 181, 2, 3, or 4. So the accrued interest that you have to pay is $40 that you receive is $40 times 15 over 183. So in other words, there are 183 days worth of interest. So each day accrues 40 over 183. You held it for 15 days. You then should get and there's some rounding here, 3.279. So two things you should be prepared to do. Number one, and if you hadn't had the finance class, I have to give some background on this. Number one, make sure you can price the bond given the payout rule. Number two, if you have accrued interest, I want you to be able to calculate accrued interest. If I say you sell the bond on a particular day. All right, the next thing that I want you to be able to do is the following. Okay, so this was easy kind of math in your calculator when you did this equation right here. Everything came in exactly. I'll put a little first power right there. Doesn't look like a 1. You know, so it's the cash flow divided by 1 plus the interest rate to the first, second, third, fourth, fifth, sixth, seventh, you know, however many years you have going out. What if you bought that bond? Like I said, what if you buy the thing December 15th, right? So the next coupon is due in less than 6 months. Well, the formula, this can't be to the first because that's not one period. So the formula here is going to be the cash flow, the $40, divided by, well, let me write this in general terms. So it's going to be the cash flow, or the coupon payment, divided by 1 plus R to the V plus cash flow times 1 plus R to the V plus 1 plus the coupon over 1 plus R to the V plus 2 plus the coupon plus the par over 1 plus R to the V plus 3. So what the numbers are, this is 40, and 1 plus R, 1.041. When I say V, what am I talking about? So I want the present value of future cash flows. So I need to know the time from December 15th. You need to know the time from December 15th to May 31st. That's not one period, so I can't say this is to the first power. Well, how long is that? Well, you gotta look at it this way. November 30th to May 31st is 183 days. December 15th to May 31st is going to be 168 days. So V is 168 over 183. In other words, we don't have an entire period here, so I can't discount to the first power. What I discount to is 168 over 183. Now let me get I'm sorry, so I wanted to do the math here. 168 over 183 is approximately 0.918. If I read that right, I think I have it right. So it's going to be 0.918. Hang on. And I'll stay in red here. This is going to be 40 over 1.041 to the 1.918 plus 40 over 1.041 to the 2.918 plus 1040 over 1.041 to the 3.918. I haven't done the math there. I don't care about getting that number. I don't want you to get lost with that. But what I do care about is this, that you get the idea, and intuition is the price of any financial asset is the present value of the expected future cash flows. What you will do in 8135, or what you've already done if you were one of the few that have taken that class, is you say, I buy a bond and the next payment is in exactly 6 months. And it's going to make, in this case, 4 payments. So I can use my financial calculator to say n's equal to 4, payments equal to 40, par value is 1,000. I, as the investor, determine the yield to maturity at 8.2% annually divided by 2 is 4.1. Then press some buttons and have the price of my bond. But in the real world, it's probably not going to be exactly 6 months to that bond pays. There is a payout rule, and it says in the contract, we will pay you November 30th and May 31st. Every November and May from this particular year to whatever. So from 2000 to 2013 or whatever the years are. It will say that in the contract. So if you buy the bond and it's not May 31st or November 30th, you're in between coupon dates. So you have to first of all find the accrued interest, which in this case is the number of days from November 30th to December 15th. That's the interest has accrued. And the next thing you need to find, if you want to find the price of the bond, the present value of future cash flows. Well, the cash flow doesn't come in one period, it comes in less than one period. In this case, it comes in 168 over 183, which is 0.918 periods. So you just discount as shown there. Alright, a couple other conventions here, and this, you kind of have to do things the way people have done them, whether it's necessarily the most logical way or not. That really doesn't matter. So what I want to talk about next, what we call zero coupon bonds. So zero coupon bonds, they have a payout rule, and the payout rule is the future value is $1,000, the payment is equal to 0, and n is the number of periods. So think of it this way. Say it's November 30th, 2011, and it's going to pay November 30th, 2013. It's going to pay $1,000. Alright, so is it a semi-annual pay bond or an annual pay bond? Well, neither. It doesn't make any coupon payments. So, since it doesn't make any coupon payments, how do I value the bond? Well, the convention is how many periods is that? There's May 2012, November 2012, May 2013. So technically it pays 0, 0, 0. So the price of this bond is the present value of future cash flows. Future cash flows is $1,000. And I have to determine the yield to maturity. Let's stay at 8.2%. Now here's where your book and reality collide just a little bit. The way people do this in the market is they say bonds, treasury notes, treasury bonds pay semi-annually. So even though that's 2 years, n is not equal to 2 years, n is equal to 4 periods. So the interest rate I need is not 8.2, but 8.2 divided by 2. So this would be divided by 1.041 to the 4th. And that's how you price a zero coupon bond. So what I think I want you to do for next class is just read chapter 14, try to get to speed on that, and I'm going to put up a time value of money video here in just a second.